Welcome back to another week of designing with Cheesy. Um, we are going to continue talking about HVAC systems, and today we'll be dwelling on load estimation, energy calculations, and zoning loads and IAQ, which stands for internal air quality and ventilation. So yeah, indoor air quality rather, which is almost the same thing. So after this, we are going to do the load estimation for building build an existing project, and then time permitting us, we are going to design the HVAC system for that building also. We've talked about ducted and ductless systems in the past, and we would be deciding which we're going to be doing today. We've also talked about residential and commercial buildings too. So let's dive into it. So load estimation is about using engineering software. I mean, you can use calculations, but that's just going to take so much time to quantify how much heating and cooling the building needs to maintain comfort. In the past, we've talked about using the rule of thumb, which is faster, but it's not always very accurate. So usually when you start using the rule of thumb, THUMB, you can go on to doing this just to confirm if you're on the right path or not, because there's some things that rule of thumb does not allow you to find out. So find out as time passes. Basically the softwares that can be used for load calculations are these ones listed here. Yeah, oh, sorry about that. These softwares listed here actually. Yeah, Coolcalc, app, this and that. But we're going to be focusing on just Coolcalc today. Yeah. Actually, Coolcalc is a method of doing manual G. And a G is the calculation. We'll talk about that when we get there, actually. So why these are some reasons why rule of thumb is not always the best when designing. Um, because when you're using rule of thumb, you don't check the orientation of the building, like where it's facing. You don't check the climate. You don't check the type of building it is. I mean, to some extent, you can estimate. Yeah, you can overestimate or underestimate. Yeah, you don't take this into consideration. The glazing has to do with glass, the windows, and any openings that are exposed to the environment. Then you also don't take consideration, okay, you do, but not very accurately, of the heat from people, equipment, lighting, and appliances. So I've mentioned in the past designs that when we are designing in certain locations, maybe an office, you also, like, if you're estimating, estimate a little higher because it has like equipment, or in a kitchen, for example, or in a space that has a lot of people. But that is just estimation. Yeah. So another thing that this takes into consideration is the outdoor air requirements, and this is usually more strict. These measures are more strict in commercial buildings. So the amount of outdoor air that is supposed to be permitted into the space to dilute and improve the air quality. Because if the building keeps rinsing and repeating the same air, recycling the same air, it gets stale. So there's need for an amount of ventilation air to enter. Yeah. Then and also need to like remove some of the air in the space too, just a way of recycling it. Yeah. Then also have buildings that don't operate full load. Definitely. Offices don't are not always occupied. Homes are not always occupied. And there's what they call peak hours and regular hours. So these are like things that you need to put into consideration too. And that's where the software is coming, because yeah, because they tell you, they usually take all this into consideration and they like do it to like a higher level of accuracy with their preset um, features. So next we talk about zoning in a building. So a zone is a space or group of spaces that have similar thermal and occupancy characteristics that they can control together. Um, in a building, for example, yeah, in a building, for example, there could be one room, and that one, each room that is covered house that is like covered by a wall, like four walls, or like fully enclosed with a space. Now there's conditioned and there's unconditioned spaces. So an example of unconditioned spaces are garage, closet, storage spaces in some cases. But conditioned spaces are usually like spaces that need to be conditioned, either because they have people in them or they have like certain items in them that need to like be kept at a certain temperature and humidity. So now, more than one space, yeah, like multiple spaces can all have the same temperature levels. So if it's a ducted system, if they have the same temperature, it's not really a problem. So you just have to connect the ducts and then drop it at each of them. Yeah. For example, now a hall, for example, the temperature is uniform across, yeah, in that space. But zoning comes in where for some reason one space needs more cooling or more heating than another space. And this could be due to different factors. So now a group of spaces is what is called a zone. Yeah. Now, reasons why zoning might be necessary or is necessary is different rooms have different solar exposure. So architects know this, like when they are designing a house or a building, they design it in such a way that they know that the north and south, the sun rises in the east and sets in the west. So they usually try to avoid that sun trajectory or that sun path to avoid unnecessary solar heat gains. Yeah. So I mean, if a space or a zone is facing the direction where sun is hitting the most, it is expected that that particular space is supposed to have a higher sorry, a higher cooling load because the heating is increased. There's a lot of sources of heat. The sun is a source of heat, a big source of heat. So they need to cool it down to a large extent, as opposed to buildings that or spaces that are not in that type of space. Another we talk about is occupancy rather. So depend on the kind of um, what the content of that space basically. If there are a lot of people, it means that that place needs higher cooling or higher heating or higher air change. You get. Then we also have and then storage too. There are some kind of storage, some kind of spaces that are storing either food items or maybe it's a computer room or it's a data room that needs to be kept at very low temperatures because it's helped to preserve these things. Yeah, and then humidity needs to be controlled too. So now that is like a different zone altogether. Because if in a building you have like the office spaces, you also have like storage spaces, there will be different zones because they are not maintained at the exact same temperature. Yeah. Then you also have different HVAC requirements. So like this like summarizes the first two. So as you are having different zones because you want this zone to have different design specifications, you will also control the HVAC requirements too. Yeah. So to meet the requirements of the different zones. So now typical zoning strategy. This is like these are examples of how to zone. Yeah, and usually comes with like bigger buildings. Yeah, because bigger buildings have like um is more difficult to maintain a uniform temperature across bigger buildings. So perimeter zone, which is like the edge of the house around the external or the most outermost uh, rooms or the most outermost spaces. Yeah, because these ones are mostly impacted by sunlight. Yeah, so they tend to gain more heat or get to lose heat faster because they are the external part of that building. Then interior zones too can be a zone. Yeah, because it doesn't. This one does not really deal with solar. Like from the sun or from wind too. Wind is another source of heating and cooling because as the wind hits the external walls, it enables the building to either get cooler faster or get basically it enables convection and conduction to take place in that building. Yeah. So in this case, in interior zones, the is mostly because of internal heat, like maybe equipment or the people in them. Then another is functional zones. This is despite the location, it will be based on what that space has or what it is, the function of that space. Yeah. Then why benefits of zoning are it improves comfort and avoids complaints. It avoids oversizing or undersizing of equipment. So like the mistake or the issues that rule of thumb would have presented you are able to avoid issues. And then it helps to enable energy savings too, because you get to have like independent control. This zone usually goes with controls, yeah. So you can set the temperatures to like a certain limits and maintain it at that limit. So you have independent control. And then also have flexible operation schedules where you could set it such a way that maybe when this other species or this particular zone is not in use, maybe in the night, you could like turn it off. The heating for that space, the condition for that space can be turned off, while the one for the other zone is kept on. So that is, it creates a level of flexibility. So you don't have to like do all off or all on at the same time. Then moving on, we also talk about IEQ, indoor air quality and ventilation. So this refers to the cleanliness, freshness, and health of indoor air, basically. So we have what we call ASHRAE standard 62.1. I mentioned earlier that ASHRAE is like, it's a body on an American organization that monitors and controls anything revolving around the air, the cooling, the conditioning of a space. It also has to do with refrigeration also. So so they have this standards. It's a whole body that has like a whole book that talks about different aspects of HVAC. Yeah. And this standard 62 in particular, it refers to, or it covers ventilation requirements. So you will need to go and read it up, because we're not going to start going into details here. So you read up on the minimum ventilation requirements for, and it's mostly this, like I mentioned earlier, it's usually stricter for commercial and public spaces, because these are places where there's like lower tolerance for systems that are not working. Yeah, as opposed to a home or a residential building. So some key components of this standard, this chapter, actually chapter 62.1, are that the ventilation rate. So this covers how much outdoor air must be supplied per person and per floor area. So depending on area of the room and the number of people there, there's this minimum amount of air, outdoor air, that must be taken into that space. Then the air distribution too. So it also like talks about like proper distribution, yeah, of supply, return, and exhaust. So as you are replacing the indoor air with some outdoor air, it also means that that air that you're replacing has to go somewhere. So that's mostly where exhaust comes in. So, so yeah, so as you can see here, we have the condition space, and then we have the HVAC system. So you see that air is being supplied to the space, then air is being returned also, and part of that air is being exhausted, while part of it still comes back to be reconditioned. So now this part that is being exhausted is replaced by the outdoor air that's coming in, outside air that's coming in. So this is part of what maintains the air quality in the room to be good or acceptable. So moving on, removal of particulates, matter, odors, whatever. Air handlers, which is AHU here, usually has filters. Yeah. So that filters usually like filters of different levels of cleanliness, or different levels of um, clearances. Yeah. That allow different levels of contaminants to pass through or to stop. Yeah. That's like a different topic entirely. Then we also have humidity control. The humidity control usually has to do like measuring or monitoring the amount of moisture in the space. And if the space is too humid, it tends to have mold growth. Yeah, that is when you see on the wall, you see the wall is a bit moist, and also like breeds some kind of health issues. So, and then exhaust requirements too. Now, in a lot of other spaces, there's usually a combination of return air and exhaust air. But in spaces like toilet, kitchen, and labs, there is very strict amount of air that has to be exhausted. In some cases, all the air has to be exhausted. Yeah, because there's no reason why your bathroom air should be recirculating. So that is why in the past design I've done and in the future design, anytime I'm designing a bathroom, I will never put a return air or a transfer grill in that bathroom. And I was even supplying there's like a limit to the type of supply because type of equipment you have to supply. You can't just hang a air handler or a mini split unit in a bathroom because of how strict these measures are. And also these things apply more strictly in commercial buildings. So yeah, so typically what we check for are like CFM per person, CFM per meter square, the area, then the zone outdoor air. There's the amount of outdoor air that must enter, and the efficiency too, the system ventilation efficiency too. So moving on, the summary of this basically is just talking about how to get the correct HVAC capacity, how to get correct HVAC capacity, then to ensure precise control because that was one of those enables more accurate control, and also to ensure healthy air while accounting for extra ventilation loads. So together they form the high performing sustainable building because as time passes, as innovation takes place, it should not be here. As innovation takes place, uh, buildings need to be smarter, more sustainable, and these are like some measures that enable that to happen. So I mentioned manual G and manual N earlier. So they are both specific standardized methodologies for calculating the precise heating and cooling load in a building, yeah, that the building gains or loses in the different seasons, and it prevents installing oversized or undersized equipment. And manual J is usually the standard for residential buildings, and manual N is the standard for commercial buildings. So that's pretty much all for our notes today. So let's quickly go into the practical aspect of the class. So we're going to do manual G for a residential building, and manual G is okay. So manual G is basically we usually use this CoolCalc website to do it. So I basically just searched CoolCalc. This is to enable you to find it yourself. I could have easily gone to the website, but we do it this way. It is a website, so it tends to be slow. I think my network is a bit bad. So let me quickly try to connect to a better network. So network is taking such a long time, and I think I might have to do something else because network doesn't appear to be on my side today. So let's do manual N instead. I initially planned to do manual G, but let's do manual N instead for today. Manual N will be for a commercial building. So let me quickly select a commercial building that I'll use for this project. So we are back up on manual G. Network has finally come through for us. And let's hope it stays this way. So the CoolCalc page has opened and I'm logging in now. Okay, manual G. So we log in after searching for it. And these are some projects I've worked on in the past. And let's create a new project. Okay, let's call it Cheesy's ADU. ADU means ADU means an accessory dwelling unit. Now this building is an existing building, but I'm going to use the actual address, but I'll try to protect the privacy of the space. So it is in South Mollison Avenue. Yeah. Notice it's already filled up, so it has given an idea of this is so that the location of the building can determine with the location can determine the climate and all of that. So moving on. So now let's go to the next page. So now this is by block load or by room. So for manual, you usually do room by room. Yeah, block load is like we've said now, it's for existing homes, and it's usually block load is when you are taking the building as a whole. Yeah, but room by room, you're going to do it room by room according to the different spaces in the room in the building. So let's moving on. Sorry about that. So now you see the different information that you have to fill in. So this, let's look at the building that we're going to be working on. Okay, no, this will not work for this. Okay, let's open the building. This is what the building looks like. It's a residential building and it's an ADU, so it's like just like a boys quarter, but it is like it's usually attached. Or it not attached, but it is usually let's go back and see what ADU means. ADU means a secondary living space on a single family property. It's just like how a boys quarter is like attached to the main building. This one is usually a separate building, but it is usually like secondary. Yeah, it's usually on the same lot as a main house. Yeah, so that is usually small. So this is what it looks like, and these are the contents of the space. Let's quickly go over it. This is the bedroom. This is the room and closet, bathroom. You can already see that there is an amount of conditioned spaces in this space in this building rather. So let's go on and see how we can accordingly can do the manager for this building. Okay. So the year, since I'm designing this in 2025, I'm going to fill in 2025 here. Okay. Then it is on the ground floor. There's no like one number of bedroom. There's one, as you saw earlier. There's only one bedroom, which is this. So it is the single family, obviously. So this is the category falls into the most. So that's how connection between. No, it doesn't. No, it doesn't. No, it doesn't. Skylight is a. So now this is on the dwelling information. Let's continue to the infiltration information. So now was a blower test performed? This is like a standard. Yeah, blower test is a way of testing how much air can be leaked, how airtight the building is. Yeah. So usually when I do manual G or manual air calculations, I assume worst case scenario so that when I'm sizing the equipment, if the scenario is worse than it is should for any reason, because what you're designing and what is built on site, sometimes there may be variations, tiny variations due to like information on ground or circumstances on ground. So if you ever have to choose between what you're not sure of, it's better to choose a worst case scenario, because if anything happens, it's like just like having a design, it is design yeah, an extra safety plan in case it doesn't. Yeah, like a safety factor basically. So I'm going to assume that blood test is not performed. Yeah. So then average. Average, I'm going to normally tight is the best, but loose is the worst. But I'm going to take average because it's a middle value. Yeah. There's no fireplace, so that is 0. So we continue. Okay. Now now let's go back and look at the building. So this one, they're trying to get what the construction looks like, the materials used to do the building, and you see, they already gave you some Okay, what I forgot to mention is that usually to set up a Cocac account, you would need to, okay, I'll see that at the end of this. So let's look at the building. Now we only have the CAD file or the drawing file, but most times when the project comes in, you will have like an architectural file or the project file that usually comes with information on the the type of building, the type of materials used. So in this case, you are going to assume that the walls are made of wood. So these are like the standard materials here. So these are the different ideas or different options depending on what your architectural file provides for you. Okay. So so this also gives an idea of the type of insulation the building will come with because there are already preset ROU values in this. So now this is ceiling under attic. This is the most common type of ceiling. Yeah, there are other types of ceiling, but this is the most common and we are already taking that as the default values in this project. So moving on, we'll further talk about the type of roofing material. And I'm going to put asphalt shingles and the color too because this can affect the amount of conduction. If you know about mechanical engineering, heat conduction, you know that darker bodies tend to absorb more heat than lighter bodies. So this is another worst case scenario. Let's take dark. Yeah, the concrete slab on grid floor. These are different types of floors. Yeah, so we take this. Take this. I mean, if other information was present, we would have used accordingly. But in this case, you don't have all the information. This is just you with a design mindset of what should be existing. So we filled in all these values and go on to the next page. So now you're going to fill information about the walls. Yeah. So already, if you remember, this what we can't edit this because this is like the is based on what we put initially in the construction profile. So now we're just going to provide more information about the walls. Yeah, above grade means above ground level. So now there are there are so these are like the standard. This is like the wall that has come in based on the information you filled in. So now this is in case you need to fill in information for other types of walls. So okay, let's go to, and then so in case you need to like add any extra information on this thing. Yeah. So let's scan through and just select. Okay, 2x4. Now this is the type of framing. So I'm going to take 2x4. Okay. As a default, obviously. But if the architectural file has a different value, usually either 2x4, 2x6, can take that. So let me take 2x6 for this. Yeah. Then cavity insulation. These are like standards already. So usually cavity insulation is, let's check what it is a type of insulation that let's work. Okay. It's usually placed inside, yeah, usually placed inside the walls. So like the name implies cavity. So when you have like frame walls, because that's what we have here, that's what we selected, frame walls. Frame walls are types of walls where, yeah, we are made of frames. So in between now, this frame now is like the bars or the frames that make up these walls, and there's a lot of open spaces. Yeah, even in this. So cavity is usually used to fill up all these spaces. Yeah, because because this wall is usually made to save materials. You can't just put this type of wood. It's usually wood, some cases, or it could be metal. If you use, look at in this case is wood. If you use wood to fill up the whole space, it's not very economic. So instead, they space it out so that the wall can still maintain its strength, structural strength, and to now make up for that, they now use cavity insulation to fill up those spaces. Then board insulation, you can actually look up all these things. Board insulation is when we have like a board, an external board that after like insulating the insides in between the spaces of the frames. Network is not very good today. Okay, so moving on. Yeah, we're going to take arrow 2. Usually, in cases where we don't know whether, usually there's like a standard value of arrow 21 here, but in this case, because I know that we are going to put a board installation of 2, I selected this as 19. So that when you add it together, I see gives 21. But then again, architectural file will provide you that information. Yeah, just scan through. Then they also have the brick veneer, yeah, which is a type of exterior finish along with the others. So I'm going to use this and save it. This is basically just filling in extra information the on the wall. Yeah. So now this was the standard wall they gave initially, and this is the wall I've added. Yeah. So now that means that moving forward, I will choose which of the walls I'll be using. Yeah. Okay. I can delete this because this came in. This is the old type of. Let's see. This was the old wall. Yeah. I don't want this wall anymore, so I want to delete it now, so that I'm left with this wall that I put in. So that means from now moving forward, I'm going to be taking it that all my walls are made with this. Yeah. So moving on to dimensions. Now they're going to ask your data source. So we are using the standard of text because map trace will involve putting your drawing and then tracing it. But that's not what we want to do today. So we're going to text means you're going to fill it up manually. So now we're going to need information on the different rooms. So we add the first room, call it the bedroom. Bedroom, yeah, because from here we have a bedroom. Okay, this is our building, a bedroom, which is this, right? So let's go on. Bedroom. Then a room type, it is a bedroom. But these are like the different types of rooms. If you notice, all the types of rooms here are like in residential buildings. So we don't use Mama J for commercial buildings. So it's still on the floor level, which is automatically filled because we initially put that it is only a one floor building. If you had another floor, this would have been where you put it. Okay. So moving on, does this room have an exposed wall? Let's check this. Okay, let's check if our bedroom has an exposed wall. So yeah, you see it does. There are some cases where there's an internal space, like I mentioned earlier, and that internal space doesn't have an exterior wall. Like if this was a space, a conditional space now, you see that doesn't have an external wall, but the bedroom does. You can see here and here. And then these are like internal walls of that space. So the whole point of asking about this is to know the amount of sunlight that is exposed to, right? So yeah, so yeah, it has an external wall. So moving on, exposed wall rather. So now they will ask now they are going to ask us to fill information on the exposed wall. So now we select what side it is on. Let's check. Now we see that this is up north. This shows that this is north. Yeah. So up is north, this is north, this is south, this is west, this is east, right? So that means let's take this wall and then this wall. This wall is exposed to the west, and then this is to the east. So let's take the west wall first. Then you need to also get the wall length. Now, which is this, right? So this is how we check for that. This is our measuring tool, and we measure somewhere in the middle from the middle point to the edge of the wall, and it gives us, oh shit, we need to check our dimensions and edit it because it's supposed to be in foot and feet and inches. So let's change that. So to change units, we simply type units, yeah, and then we go here, and then we set our units. So architectural could be engineering, but let's just stick with architectural because everything comes for architectural. Then architectural then is in inches, feet. Let's put feet, right? And then the precision is, let's leave it at this, right? So precision, let's leave it at this decimal degrees. Yes, that is correct. Okay, so feet, right? Okay, so this is lighting. Doesn't really matter in this case, but let's just put it at American because we are working with American designs, right? So this is what it should look like. So let's see. Let's do this and see what it, so now let's try. Let's okay precision. Okay, this is like to what extent, basically get what it means is like how accurate you want it to be. Let's leave it at this because yeah, that thing should be set to inches. Okay, my mistake. So units set to inches, not feet. Inches, right? Okay. Okay, let's leave it at this. So now let's try measuring again. So for somewhere in the middle to this. Oh, it was actually giving us in inches all this while. Right, but I need it to be in feet because I need to be close to the feet. Let's do it again. Okay. Oh, give me a second. So I was doing the wrong thing. I needed to, the units already set correctly. So now let's go to dimension settings instead, which I'm accessing by typing dim. Yeah, okay, let's close this. Okay, dim style, right? So now this is the existing style. So I'll set it as standard and then I'll modify, right? So when I modify, I can set all the things I need to set. Okay. I don't need all this extra. I need it just like this. Architectural. Okay. And close. So this is for the dimensions. Okay, now let's check and see if it's different. Yeah, this is what we want. 10 feet, 5 inches. 10 feet, 5 inches. So let's go back to our drawing. So this wall is 10 feet. And usually the wall doesn't allow for like decimals. You can't put 10.5. Yeah, enter. It needs a valid, has to be a whole number. So since it's less than 10.6, I'll approximate it to just 10 inches, right? 10 feet rather. So this window area is like an approximation of the amount of windows on that space, on that wall in particular. So let's check. So there's no window on this wall at all. So that means the window is, let's see. Yeah. So it's not medium, it is none. If there was a small window, it could have been one. So that is none. Number of doors, there's no one on that space, so that is 0. So now we add another wall because we have here another wall on the, so this is the west, so this is the southern wall. So we have another wall here. So let's add this wall. Actually, our building does not have any windows at all. But I'd love to do this with the building that has a window, but maybe that'll be another day or another time we have this discussion. So now this is our south. So now let's measure the distance of our south wall. That will be from here to somewhere in the middle. That is exactly 10 feet. So our room is actually a square room, kind of. Okay, actually, yeah, a square room. So let's go back here. So our southern wall is 10 feet, and then it has no windows too, no doors. Or is there any door? Let's see. So there's no door on this place. So that is all the walls we are going to consider for that room. Now we save it. Right. So now we need to add another room. So we go back to the room information, or the first floor rather, and then we've added information for the bedroom. So now let's add information for other rooms. So we have another room, which is the living room. Living room. Yeah. Living room. Let's see what the architecture named. The architect named that space. Okay. So yeah, it's a living room. This is here. And if you notice, the surface doesn't always match in some cases, because, for example, now this was a 10 feet by 10 feet room, and I wonder why it doesn't match. Let's check area. Okay, let's check why it doesn't match. Or is it because we took it from, okay, okay. So press enter and it gives us 86. So yes, so this means we make, okay, why it didn't match is because, it's we are taking the walls into consideration also, right? So this wall on the interior wall, it starts from here and ends here. But when you look at it from the exterior wall, all the heat that enters this room is actually taken off from this actual distance of external wall. So that's how we use the external wall length instead. Okay, so moving on, let's talk about the living room. The living room has how many walls exterior? We have the south wall and the east wall. Now, there's if because this is an ADU, they put the living room and kitchen in like in a similar space, like together, basically, only separated by this line, which is not a wall. So we are going to analyze as if it is separate rooms. So let's do that. Let's do that quickly. So that, because they have different areas and all of that. Okay. Let's see. Let's see. So now, so yes, I'm looking at the living room. I'll tell you what type of room is it. Living room. It's level 1, average, and now it gives you an average room height, which was like earlier, and is 9 feet. But then again, if for any reason the building has a higher height than this, it's going to state it for you, right? Now, does this have exposed wall? Yes, it does. So we continue. So now the exposed walls are on the south and on the east. So let's take the south first. So the south is this side, this part. So let's measure it. We're in the middle to the end. So that is roughly 10 feet. 10 feet. 10 feet. Then there are no walls there. Let's see, are there any walls? There are no walls, but there's a door. Good. Love this. So the window is none, but there's a door which is 1. Okay, just increase from here. Okay. Now we add another wall because there's another exterior wall or external wall. Okay. Now let's check the length of this wall. This is the entire wall. Okay, no, we are going to stop here because we're taking it as a separate space. Okay, let's measure once again. So that'll be from here to where it meets. So that is 13 feet 4 inches. Take it as 13 feet. Oh, we don't need to. We need just one. So that is the east wall, and it's 13 feet. 13 feet. Then there is no window on that wall. None. And then there's no door also. Let's confirm. So it's just one straight wall. So none of that is there. So that is all for that space. So we save it. Oh, okay. A bit of mistake. Yeah. I was in a hurry to rush back. So we're supposed to actually fill up all this information about that space. Let's go back to the first space, which is the bedroom. Okay. So now we filled in this information, filled in the walls, now the dimensions of that space. Yeah. So now want to confirm the room area. Remember we had that issue of it being 86. That's 86, which is the actual room area, entire room area that we measured. For area is equal to room area. Yes, that's true. So area equal to, yeah, that's true. Okay. Next, talk about the ceiling. So now, this is that ceiling that we selected in that initial time under this construction details. So yeah, if there's another type of ceiling in that space, I would have added it here, but we're going to stick with this ceiling. So floors. So now we're getting like the summary of the information we've put in so far. Now the internal loads. Now we are not in this building, but we have an idea of what are the things that we have in that building. So all our occupants, one bedroom is having like one occupant. One bedroom is one occupant. Yeah. Then our small plants. Let's see one. Number of medium plants, 1, 2. Depends on the kind of person the person is. Let's just say 1 here. And then 0 here. Just this is us trying to make estimates based on what we think. If it was a bigger room now, maybe a master bedroom now, would have taken one small plan, one medium plan. But let's just leave it at one medium plan, which is just basic. Yeah. But no large plants. So now this is for like the appliances in that space. Okay. So now there might be a ceiling fan, right? Quantity 1, save. Let's add something else. Let's see what else we can add. These things are basically not in the room, in the bedroom. Okay, let's see. Light fixtures. Light fixtures, they're always light fixtures. That is the bulbs. So let's take that. There will be 2 in that space. It's a small bedroom, so 2 is fine. Yeah. So I think that is good. Let's see if there's any other thing we can add to this space. Mm, no, no. Okay, that's fine. So let's leave it at that. Now save it. So now I've put all the information about that space, right? So this is just to give, this is like an idea of the amount of load, heating load or cooling load rather, the amount of load that that's heat that those equipment or the appliances will produce. So now let's go back to the next page, the next room rather. Okay, which is the living room, and fill up the extra information. We've done this. So now this. Okay, let's confirm the area of that space. The architect gave it to us, thankfully. So it's 116 square feet. So you see that there's slight differences. That's why we have this page to make up for it. So yes, yes, save. Always save every page. Then next is ceilings. Nothing to do here. Floors, nothing to do here. Internal load. Now we're talking about a living room. So you see that they already gave us automatic two occupants, because when we are doing calculations for a building, the occupants in a building is usually, or in a residential building, is usually the number of bedrooms plus one in most cases. Yeah. So we're going to leave it as two. Yeah. Then number of small plants, let's put it as one. See, they've even given us some average values already. But this is too much. Let's keep it at one and leave this as one, two. One. Okay, let's increase this to two because it's a living room. So maybe some for aesthetic, some for just to like scatter around the place, and it's also slightly bigger, right? So now they've already given us some plants that are expected to be in that space, but I don't think we'll have a computer and monitor in that space. But since we are looking for highest best case design, scenario design, let's leave it at that. Then three lighting fixture. Let's see if there's anything that we can add again. Um, okay, let's see what else have we not added. Nothing again. Okay, nothing again. Let's leave ceiling fan first, because this is mostly guessing. So already, why don't want ceiling fan? Okay, let's also add a ceiling fan. Usually, I don't add ceiling fans all the time because they they usually just supplement the already existing HVAC equipment. So ceiling fan, you see, you didn't even add much, right? So now this is the wattage of each of them. So now we save it, right? So now we go back to this floor. We need to add more spaces. So this is, now we add the kitchen. Type in kitchen. Kitchen, right? So what type of room is it? Kitchen. Floor level 1, height 9. Yes, it does. So let's move on. Okay. Now let's check the walls that are exposed. So this is our east wall, and this is our north wall, because up is north. Our north wall and it ends here. So let's measure it. Measure our north wall. North wall is somewhere here to the end, which is 10 feet. So we go back here and fill in our north wall and put 10 feet. Right now, there's no window on that page, on that wall rather. There's no window there, so there's no need to fill information on window. There's no door either, so number of door is 0. Number of windows or window area is none. Okay, I add another wall, which is the east wall. East wall. So add it. Okay, see these people. Okay, so this is the east wall. Now let's check the length of our east wall. So it's just from here to here. Let's check. 6, 8. So we're going to approximate it as 7. Now that extra 4 that we lost, that time we took only this 4, we're going to get it back when we take this as 7 feet. So we'll take it as 7 feet. 7. Now there's no window and no door too. So good to go. Now this window and door would have been like sources of loads, because doors allow air to enter into the space and the windows allow sunlight to enter into the space. And if those were the cases, they would have put it into the calculations as well. So save. Now we're going to the room dimensions. Let's confirm the size of that kitchen space. That is 51 square feet. That's a really small kitchen, by the way. 51. Okay. Yes. Yes. Now you save it and go to ceilings. Nothing to change here. Go to floors. Nothing to change here. Internal loads. Now that is the kitchen space. There's no occupants. Nobody usually lives in the kitchen. Occupant is just like who dwells there for a while. Nobody really dwells in the kitchen. So we're going to leave it at 0. Well, the whole point of occupant was like the no amount of, is because they're trying to consider the amount of. Okay, let's put it at 1 actually. Because when the kitchen is in use, there's at least one person there. Right? Now number of small plants. You see, they already gave us some default values. Assuming that there's, but I'm going to set it as 2. It's a small building. Set it as 2 small plants in the kitchen. Then you see they already give us some things. So range with wood, right? Okay. I wonder why they didn't attach values, watt values. Let's see. Refrigerator. Okay. Refrigerator. 1. I wonder why they didn't add. But there's usually supposed to be wattage here. Maybe it's insignificant, but there might be an error somewhere, right? So now we leave it an exhaust outdoors. I'm wondering why, but let's put other things and see what happens. So we didn't put lighting fixtures. Let's change that. As lighting fixtures is okay. We're going to put 2 because it's important that the kitchen is well lit. Right. Okay. What else can we add? Dishwasher is already there. Let's see what else we can add. Toaster. This is a small kitchen, so it's unlikely that we're going to have this thing. Oh, yes. Yes. Let's see. Range with no hood. Let's see what happens when we add this. Range with no hood. There's still 0, and I'm wondering why. So let's delete it. Yes. Yeah. Right. So I think that we are good to go. We're good to go. Okay. Let's change this back to 2. You see that it what happens when you don't save. When you don't save. So this is 2. Let's leave it as 2. Save it. Oh, we also didn't change this. Okay. The page refreshed. That's why this value changed. But when you save it, even if you refresh, it doesn't change anything. So let's see again. Okay. It has saved all that, right? Now let's go back and add the final room, which is a bathroom. Okay. So all this is the same, right? So now let's check which walls are exposed in the bathroom. In the bathroom, this is the bath. Okay, it's actually bath, not bathroom. But let's leave it at that. So we have the north wall and the west wall. So let's measure it. And both of them have no windows or doors. Okay. So the west wall is 6 feet. Let's view that. West wall, 6 feet. No windows, that is none. No doors. Add another, which is the north wall. The north wall is here. So let's measure that. So in the middle, that is exactly 10 feet. So now we go back here. 10. None, since there's no windows. So now we save. Correct errors. What error? Oh yes, we didn't select this. Okay. So we have saved that information. Now we're going to the room dimensions. The space is, I believe you understand how this is roughly calculated. It's from the wall length you are putting in. So now let's put in 47 because that is the area of that space. 47 square feet. Right. So we've saved it. So now ceilings, nothing changes. Floors, nothing changes. Internal loads in here. For a bathroom space now, number of occupants is 1 when it's in use, right? And then number of small plants. You see, they didn't put any this in here, but me is on my own discretion. I'll just add 1 small plant just because I can, right? So let me not add any plant. I already added plant in every room. There's no way that we plant in every single room, right? Right. So now let's see what other loads we can add here. Let's see. Clothes washing machine. Did we add it in the kitchen? We didn't. But this is a small space, so I doubt there'll be a clothes washing machine in this space, right? In the small bathroom, rather. Dishwasher. Okay, let's add light fixtures. Put that as 1. Leave it as 1. So what else are we adding? Let's see. What else can we add? Nothing else really. Nothing else. Nothing else. Okay. So now this has changed. Let's change it back. 1. Increase it here. 1. Okay. So now we save. The whole point of all of this is to get the amount of loads that that space has. Does that particular space. Now we save. So now let's go and check if there's another room that we need to look into. So now the other room that we need to look into are the closets, which is quite small, so we ignore it. And this looks like it's safe. Not sure what this is, but it looks like either it's safe or a laundry kind of thing, which is not conditioned either. So we're going to just ignore it. So now let's move on. So we've done all of this. Now we get to the HVAC systems. Okay, now we add what kind of system are we using for this piece, right? So now HVAC system, we call it HU1, right? So there's both heating and cooling. Yes, let's save all the rooms. Yes, it does because it's one system, right? Yes, it does. Then is it ducted or ductless? I'm going to select ductless because for this piece, I'm going to use, like I've already decided that I want to use a ductless system to show this piece. So I'm not going to start connecting dots for just this few space. I mean, it could work, but it's so small. I'm just going to hang 1 mini split here and 1 mini split here, and then I'll use a fan to ventilate the bathroom. So let's do that ductless, right? The whole point of ductless and ducted is because usually ducted systems, the efficiency is lower because the air has to travel distances for getting to the space. But ductless, the air handler that is hanging on that wall, it delivers all the air directly into that space. So the efficiency is different. So that's why this is important, right? So indoor conditions, these are like some standard conditions. So we're not changing anything here. And then in-house ventilation. So this is a case where we may need to like introduce ventilation. No, I spoke about the amount of ventilation that is allowed, but it's a residential space. So even if you don't add your own special ventilation, it will pass because it's a residential building, right? Although if as an engineer you want to like go the extra mile and start looking at these methods of ventilation, feel free. But you are designing like a simplest system possible. So blower motor, performance data adjusted. Yeah, nothing to change here. And nothing to change. And also, if you notice, some more information is already pre-filled because when you put in the address of the building, it already gives an idea of the standards in that place and then the codes and all of that. So some things are pre-filled. It's not if you now want, you can change it based on existing knowledge that you have. So now does you don't have it. Thinking, no, remember, worst case scenario. No. But this worst case scenario does not mean that every time you should assume the worst. It's just in cases where if you're not sure, yeah. If you are going to, it's not as if you design the worst possible. This is just like for a factor of safety, right? And it's not in all the cases. You just find a balance, basically. So okay, I'm supposed to save first. Okay, let's continue. Right. Okay, okay. So now the next. Okay. Oh, right. Okay, let's look at our MJ report. Let's just view the reports. Normally, why I said this was what I was supposed to mention sometime earlier, where your account should have, like your CoolCalc account has like a space for your company should be the one to open it. Or if you are a freelancer, you're the one that has it as your account, right? And they're supposed to like load it with some, you're supposed to use money to buy some credits, right? And anytime you print a report, it deducts credit from that. So how you're going to fund that credit is up to you, right? So in this case, my account already has credits in it. So let's just view the reports, right? View the reports. Okay. So for some reason, the full report did not come up. I think that's the network. But yeah, we have like a summary of the loads. So the building has a heating load of 4,000 and the cooling load of 10,000, which is almost 12,000. And I remember seeing one time that 12,000 is exactly 1 ton, and also is equal to 400 CFM, right? So that again is just a rule of thumb, right? But now we see that this gives us a more accurate value of the amount of heating and cooling this place requires, right? So now let's compare and see if we are here to do um rule of thumb. Let's see what it would have given us. So this space is 86. So times 0.8 is about 60 something, right? CFM. Let's take the total space basically. 86 plus 116 is um 16 plus 6. Let me use the calculator. My head is not very in a space to start this thing now. So 86 plus 116 plus 47, 47. That's the bathroom plus 51, 51. That is roughly 300. Exactly 300. Exactly 300. You can calculate it where you are. 300. And now, normally would have multiplied by, let's see, 0.8, right? Oh, okay, let's just do this first. 0.8, and that would have given us 300 times 0.8. That is 240. Now, because of spaces like kitchen, I would have raised it up to like 300, 400. So you see that um, um, rule of thumb is sometimes is close, but not in all cases, right? Not in all cases. And another thing we notice from this is that it has a higher cooling load than heating load. So from all the loads we put in and from like the exposure to the environment and climate of the place, it means there'll be a lot of heat in that building. So that's why the load of cooling is higher. So it means we need to ensure that we are able to meet the cooling up to this BTU, right? The heating, not so much. Not we don't need to do too much heating, but there's still need for heating, right? So right, that's pretty much what it would have looked like. Right. Let's see if this works. Well, it's still not working. But we've gotten what we want, which is the heating and cooling load. So now we can proceed to designing the layout for this space. Right. So let me know what you think is the way you'd have designed the HVAC system here. Now that you know that the highest load is 10,000, close to 11,000, and it requires CFM of roughly 400. Tell me how you are going to design the HVAC systems for this. Thank you.